Okay, guys, so this is part 2 of our revision series on halogens. In part 1, we introduced the halogens, talked about their physical properties, and now let us discuss their chemical properties. Now, as stated before, halogens react by gaining electrons in order to form anions, negatively charged ions. And out of all the halogens, the one that is most reactive is fluorine, and the one that is less reactive is iodine. So let's start with the first one, reactivity with metals. How do halogens react with a variety of metals? Number one, let's talk about how chlorine reacts with iron. So if you were to take iron, heat it, and then place it in a jar containing chlorine gas, what will happen is that you're going to have dark brown fumes being formed. So in the reaction, iron will react with chlorine to form iron 3 chloride. This is a brown substance, but it sublimes. Remember sublimation? Now what happens is that this reaction is exothermic. It produces heat. Have you ever carried out a particular reaction in a lab and then you're holding, for example, a boiling tube and suddenly you feel that it's warm to the touch? Then that is an exothermic reaction. So certain chemical reactions give off heat energy. And this is one of them. So in this case, when iron reacts with chlorine, it produces heat energy. So the heat energy that is produced causes iron 3 chloride to sublime. So the brown fumes that you are seeing are actually this product. Now I would like to say this. Halogens, including chlorine, are highly poisonous. So the experiments should be carried out in a fume chamber or in an area that is well ventilated to prevent poisoning, of course. So iron also reacts with bromine to form iron 3 bromide, and it reacts with iodine to form iron 2 iodide as such. Now, what if you were to react sodium with chlorine? Again, sodium is going to react with chlorine gas to form sodium chloride. So just to summarize, magnesium, aluminium will also react in a similar way with the halogens. How do halogens react with water? Are halogens even soluble in water? So what happens is that solubility of halogens in water decreases down the group. This simply means that fluorine as well as chlorine are soluble in water. Bromine not as much, and iodine is only slightly soluble in water. So if you were to take chlorine gas and dissolve it in water, it's going to form a yellow solution. This is known as chlorine water. Now, chlorine water is a mixture of two different acids. We are going to have hydrochloric acid and hypochlorous acid inside. So hypochlorous acid is also known as chloric 1 acid. Now, as stated before, chlorine water is yellow in color. It's a pale yellow color actually. But what happens is that if you leave it for some time in the presence of sunlight, what will happen is that it's going to be decolorized. It's going to turn colorless. So it turns from a pale yellow color to colorless. What has happened? Now in chemistry, if you see a color change, then that means there's something that has happened. So in this case, remember what we said about chlorine water? It is a mix of two acids. Now, hydrochloric acid is a stable acid. It's okay. It doesn't break down. It is the way it is. But when it comes to chloric 1 acid, this is unstable. So it breaks down, leading to the formation of hydrochloric acid and an atom of oxygen. Just look at the formula of chloric 1 acid. It's HClO. Now look at the formula of chloric 1 acid. When it decomposes, it leads to the formation of hydrochloric acid and an atom of oxygen. Now hydrochloric acid is colorless, as you know, and that is the reason why after some time you're going to have the solution turning from a yellow color to colorless. Now chlorine water has bleaching properties. So when we talk about bleach, this is a chemical that is capable of removing a dye or a color from a substance. Now, if you have chlorine water coming into contact with any substance that has a dye in it, you know that it's colored, it can bleach that compound. It can remove color from that compound. Now, let's talk about the mechanism. How does this work? So again, When chlorine gas dissolves in water, it forms chlorine water. This contains the following two acids. What did we say about chloric 1 acid? It's unstable, it breaks down, leading to the formation of hydrochloric acid and an atom of oxygen. Now, this is what we are interested in, the atom of oxygen. So, this oxygen atom will combine with the dye present in the material. Now, by doing so, it causes the substance to become colorless. And this is how chlorine bleaches by oxidation, by adding oxygen onto the dye. So by changing the chemical composition of the dye, it essentially causes it to lose color. And this is permanent. There's no going back from this. Now, I want to give an example. What will happen if you were to take red and blue litmus papers, moisten them, have them come into contact with chlorine gas? They are going to be bleached. So chlorine will dissolve in the moisture present in the litmus papers to form a mix of hydrochloric acid and chloric 1 acid. So the hydrochloric acid has no bleaching properties. It's the chloric 1 acid that interests us. Now the reason is because chloric 1 acid is unstable. It's going to break down, decompose to form an atom of oxygen, which will then combine with the dye, causing it to become bleached. Now, let's start with the blue litmus paper. What will happen is that immediately it comes into contact with chlorine gas, you're going to have hydrochloric acid being formed. So the hydrochloric acid will cause the blue litmus paper to turn red because blue litmus paper is in an acid, red, okay? Now, when the chloric 1 acid then decomposes, it will release oxygen, which will then combine with the dye, causing the red dye within the litmus paper to now turn white, to bleach it. So you're going to have a succession of color changes, blue to red due to the presence of hydrochloric acid, and then red to white. Why? Because of the chloric 1 acid decomposing. Now, what about our red litmus paper? So red litmus paper is not going to have two color changes, just one. Because if it comes into contact with the hydrochloric acid, it will still remain red. But with the chloric 1 acid decomposing, it's going to change from red to white. Now, there's usually a trick question that students get asked whereby they are told chlorine gets into contact with dry litmus papers and give the color changes. You're not supposed to, there are not going to be any color changes because for chlorine to bleach a substance, you need to have water or moisture. So if you're talking about dry litmus papers, guys, there's nothing there for chlorine to do. Now, I have this fascinating experiment that I would like to show you. Instead of the litmus papers, you can also use flowers, colored flowers, because they contain dyes in them and they can also be bleached by chlorine. Take a look at this. How interesting is it, right? So, this brings us to the end of our lesson today. See you next time.